Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with EnGenius. Today's host is Brian Slayman. He is their product line manager, and he will be presenting today. If anyone has any questions, please submit them in the question box, and I will ask them of Brian at the end of today's presentation. Brian, thank you so much for being with us today. We're looking forward to what you have to share with us. I am finished for now. Please go ahead and take it on over.
Okay, thank you, Julie. Thanks to Microcom for hosting this webinar. So we really appreciate that. Again, my name is Brian Slayman, and I'm with EnGenius Technologies. I'm one of the product line managers. I actually have Eddie Lee here. He's also a product line manager for EnGenius. So I'll start the presentation. As we move down through the presentation, you'll hear from Eddie at the later point of the presentation. But today's topic is Wi-Fi 6. Wi-Fi 6 is a new standard, a Wi-Fi standard. It was just ratified recently. So this is what the topic of today is. What I'll cover is the future Wi-Fi demands, Wi-Fi 6 technology, and then the EnGenius Wi-Fi 6 solution, which can be found at Microcom, so specifically our 4x4 access point, and I'll talk a little bit about that and the features of that particular product. But to understand Wi-Fi 6, we have to first talk about the future of Wi-Fi demands and what we're seeing in today's market and what will be coming down the pipeline, and then we can start to talk about and understand the technology a little more. So we'll start with the Wi-Fi demands, specifically client density and bandwidth. Those are the two items that continuously creep up, meaning we have more bandwidth that we need to be using. We have more clients that are coming on the Wi-Fi network. So these are the two major demands that we look at. And this really gives us a good starting point when talking about Wi-Fi 6 and why we have Wi-Fi 6. So wired and wireless traffic. So by 2020, the question is, what is the split between wired and wireless traffic? Meaning, how many devices are on wired networks and how many devices are on wireless? And when I say wireless, I mean Wi-Fi and cellular. And so currently, well, not currently, but in 2017, the breakdown was there's about 48% wired traffic and about 52% wireless traffic. Again, when I say wireless, I mean cellular phones operating on cellular or cellular phones operating on Wi-Fi. So it's a mix of cellular and also Wi-Fi. So we have to look at that whole number and understand, okay, what is the trend between wired? And what I mean by wired is a device that is physically connected into a network like a desktop, maybe a laptop, something like that, or even a network printer, for example. That's wired traffic. So the breakdown is 48% to 52%. So what they're expecting by 2022 is wired traffic will drop to 29% and wireless traffic will increase to 71%. So you can see that going from wired to wireless, the trend is everybody's going to wireless, which I think is an obvious thing. Everybody that's communicating today is operating on a laptop or a cellular phone or a tablet, and they're all wirelessly connected to the network, and they're wirelessly connected to an access point, for example, or a cell tower, for example. So we see this trend of people moving from wired to wireless. Wireless client device demand. On average, how many connected devices did one person really have is the question, right? What was it in 2017 and what will it be in 2021, for example? The number of devices per user, how we typically calculate and deploy Wi-Fi networks is we used to look at general applications would be, we say 2.5 Wi-Fi devices being connected per person, such as a hotel installation. If you're going into a hotel or you're designing a network for a hotel, how many devices per person will they have that will connect to the Wi-Fi? And that's a 2.5 devices. In high capacity situations or applications, such as a conference, they may have 4 Wi-Fi devices. So we use this number to calculate how many access points we need to deploy to be able to handle all these client devices. So that's the number of wireless devices per user. So one person having 2.5 devices or 4 devices. So the number in 2017 was 8 connected devices per person. Now, this number, or these numbers that we're looking at, it's been pulled by Cisco Visual Network Index. And it's a study done across wireless and wired networking. And this is where the source of information is coming from. So I want to make sure everybody knows that. So in 2017, 8 connected devices per person. That's wired and also wireless, right? So we know that about 8 devices can be connected per person, right? By 2021, they're saying that there will be 13 connected devices per person. Now, I just said from wired to wireless, there's a transition going to wireless, right? The other thing that we're looking at is the number of devices. The number of devices per person is also going up. And the majority of those 13 devices that we're looking at right now, that's increasing per person, will most likely be wireless in some form, some ways. So watches, tablets, phones, laptops, and so on. Even glasses, we're starting to see more wireless glasses or Wi-Fi glasses. So that number is increasing. So the number of people that are jumping onto Wi-Fi, the number of people or number of devices per person are jumping onto Wi-Fi. So these are 2 trends that not only our company is tracking, but a lot of different companies are tracking. The other thing that we need to look at is not only the devices per person, but devices within a network are moving to Wi-Fi, specifically in the IoT market. And everybody, I think, is really aware, very aware of the IoT market, which is the Internet of Things, meaning all of these devices that sit in your home, anywhere from a light bulb to a refrigerator to door access to you name it. It's becoming wireless, and they're communicating wirelessly to a Wi-Fi access point, for example. So the number of those devices is dramatically climbing. And so some of these smart home devices, as I mentioned, or some of these smart devices are doorbells, garage door openers, microwaves, refrigerators, dishwashers, and so on. In the office, it might be lighting, it might be HVAC, surveillance, door access, security, bring your own device type of things, projectors, sensors, irrigation systems, and so on. So in smart schools, for example, their IoT devices might be lighting or HVAC or irrigation systems. So we see this number dramatically climbing within this industry too. So number of people are going to wireless, the number of devices per person are climbing, and then the number of devices that sit within a Wi-Fi network are also growing with the IoT industry on its way. So the other thing that we look at is bandwidth. Bandwidth demands obviously grow. I don't think I need to talk about this in great depth because we see this and live this every day. Where everybody's watching Netflix and high def at home, and actually a lot of video streaming on YouTube within the office. There's a lot of how-to videos. So we see this in the office applications a lot of the times where actually people are learning from YouTube. So there's high def video that's happening. And I mean, that could also be considered as video conferencing with Skype, online video, like I said, Netflix. File sharing is becoming larger and larger. Online backups, social media, obviously, there's high def images within social media, music apps. And we see this across personal networks, business networks, enterprise level networks. So this is another thing that we need to consider is the demands of bandwidth among these devices that are tripling or doubling and tripling within the network. So these are the demands we see today, and these are the demands that we are running into. Applications driving higher demands. So for smartphone, for example, you have social media, you have video streaming, web browsing, video streaming, image sharing, communication for smartphones. Also with tablets, very similar, but more tablets, you're doing video streaming, web browsing, social media, and more video streaming. So there's a lot happening on these smaller devices that we carry around. And this could happen in, say, for example, in a hotel, in a residential environment, in a assisted living, for example, senior living. So it's happening pretty much everywhere, residential spaces, MDUs, and so on. So this is another demand that we continuously look at, right? So about 71%, meaning by 2021, Wi-Fi and mobile devices will account for 71% of IP traffic. 13.4 connected devices per person will grow from 8 to 13.4 devices by 2020. Fixed IP traffic will grow at a compound average growth rate of 24% between 2017 and 2022. Wi-Fi connectivity is approximately 2.5 times faster than mobile data. And the reason I bring that up and I showcase this is because if Wi-Fi is faster than cellular data, what do you think users are going to use? They're going to use Wi-Fi over cellular. You're only going to really use cellular when you're in a desperate need of data communication. So currently Wi-Fi is faster than cellular, even when you're talking about 5G, for example. North America will experience the highest speed growth, up to 83.8 megabits per second on average. Like I said before, IoT connections will be 51% of the total devices of connections by 2022. So all these stats make sense, and this is the future demands of Wi-Fi just in general. So where do we see this demand? Like I said before, we see it in smart homes, business offices, medical offices, small to mid-sized hotels, assisted living, K-12, private schools, retail shops. So we pretty much see it everywhere. Even in the smart home space, I can say that I probably have 40 devices connected. And if you think to yourself of all the devices that are connected, you would definitely count more than 10, 15 devices. I just recently added light bulbs into my network, and they're operating on Wi-Fi. So you just start thinking about all the connected devices just in the home. Imagine what that means in a school, what that means in a hotel, what that means in a business, right? So Wi-Fi 6, that's where Wi-Fi 6 comes in. Wi-Fi 6 is known as high efficiency Wi-Fi. And we'll talk a little bit about that and why Wi-Fi 6 or 802.11ax is the latest wireless solution to help with these demands that we just talked about. So some of those features within Wi-Fi 6 really help us with, at the end of the day, high density, meaning a lot of devices communicating at one time, simultaneous users on a particular network or per an access point. How do we have all these devices wanting all this bandwidth? How do we achieve this? How do we get this to work properly? So how Wi-Fi 6 was designed was they looked at 11AC and how it was implemented into enterprise type cases like stadiums, for example, and they looked at how it communicated and what problems they saw with 11AC within these high density, extremely high density scenarios. And based off that information, what they determined is Wi-Fi 6 and these particular features. And the very first feature and the most important feature is OFDMA. And now I'm not going to deep dive into the features. We'll just high level talk about these features, but OFDMA is probably the most critical feature of Wi-Fi 6, and that enables more efficient channel use. It reduces latency between access points and client bridges, and it operates on 2.4 gigahertz and 5 gigahertz. And that's really important to understand, that it operates on 2.4 and 5 gigahertz, because 11AC only operates on 5 gigahertz, whereas 11AX or Wi-Fi 6 operates on 2.4 and 5 gigahertz. And that's really helpful to understand because a lot of the IoT devices, remember I said 51% of the connected devices will be IoT. Most of those IoT devices operate on 2.4 gigahertz. And so 11AX or Wi-Fi 6 operates on both 2.4 and 5 gigahertz, and it allows an access point to communicate to multiple devices at the same time versus 11AC and beyond. A access point could communicate to one device at one time, and then once it was done communicating with that device, it could then turn its attention to the next device and then communicate with that device. With OFDMA or Wi-Fi 6, I can communicate to multiple devices at the same time. And that's up to 32 devices, I believe, that you can communicate at the same time. The other feature is uplink and downlink multi-user MIMO. And by the way, OFDMA works in uplink and downlink. So that you know, I don't point that out in this presentation, but so you know, it operates in both manners, uplink and downlink. Multi-user MIMO was introduced with 11AC. Multi-user MIMO is a way that we can communicate with devices simultaneously at a high bandwidth. And what that allows us to do is it allows us to communicate at a faster speed and direct our attention to specific devices like phones, like tablets, like laptops, for example, and direct the radio technology or the energy towards those devices so you have a better connection, giving you better speed. And that was happening within 11AC just on the downlink side. Now we can do it downlink and then uplink. And so 11AX allows you to do that, uplink and downlink, or Wi-Fi 6, I should say. But this does it supports up to 8 clients, whereas 11AC could only do 4 clients. Wi-Fi 6 can do up to 8 devices and provides greater network efficiency and focuses the radio energy on specific users and it ensures optimal signal and reception reliability between those devices. Just a quick note, if I'm in a high density situation, I am utilizing OFDMA. If I'm in a low density, maybe I'm in a law firm where there's not a lot of users, but there's a lot of bandwidth usage between the devices, I'm going to use uplink, downlink, multi-user MIMO. I'm going to take advantage of that. Other features are 1024 QAM. This basically is boosting the throughput by 25% and provides greater reliability in shorter distances. So we're moving from 256 all the way up to 1024, giving us greater bandwidth. Longer OFDM symbols enables shorter wait times between data transmissions and tolerates more noise, which allows greater coverage. And this really allows us to perform really well in the outdoor scenarios. It also allows us to bring the access points down lower when talking about communication between our access point device and the client device. Target wait time. This is really critical when you think about IoT devices. It reduces power consumption and schedules wake times and extends client battery life of the mobile device or the IoT device. Let me give you an example of that. My doorbell, for example, needs to do a health check with my Wi-Fi access point. And it will attempt to do that, say, every 100 milliseconds, for example. And it will do that 100 milliseconds. Every 100 milliseconds, it's communicating to my access point. Well, what happens with that is a couple things. First, it's requesting a response from my access point. So it makes my access point busy to communicate with the device itself. The other thing is it's causing contention in the air. It's causing interference in the air because now I'm reaching out wirelessly to the access point and having the access point communicate back with me. That's actually causing interference. A lot of people don't know this, but a majority of the interference comes from the client device. My door ring bell is noticed as a client device. So when my doorbell is going to my access point or my wireless router, it's actually causing interference in the air. The other thing it's doing is if it's doing it every 100 milliseconds, it's using up the battery of the device itself and it's sucking the battery life out of my doorbell. Well, with target wait time, the access point can negotiate with the doorbell, for example, and it can say, okay, do not communicate with me in 100 milliseconds. You can check back in 500 milliseconds or 1,000 milliseconds, for example. And then what that does, there's less contention in the air, less interference in the air. There's less action for my access point or my wireless router to do. So I'm freeing up time there, and I'm using less battery life of the particular device itself. Another feature is BSS coloring and spatial reuse. BS coloring tags packets with a color to differentiate between adjacent server sets or other BSSs. And once it's tagged with that color, you can actually use spatial reuse to enable simultaneous transmissions on the same channel. So on a very high density network or neighboring networks, you get less interference in the air or less collisions in the air when you use something like when you use BSS coloring, spatial reuse. And that's the extent I'll talk about BSS coloring and spatial reuse. There's a lot that goes on with that, but that is the basis of BSS coloring and spatial reuse. So those features there are many features within Wi-Fi 6 or 11ax. They're the main features that a lot of people like to talk about and highlight, OFDMA being the most important one. And so EnGenius, to meet these demands of wireless networks that are current and coming, there's even more coming with the growth of bandwidth, the growth of number of devices per person, and IoT devices. To meet that demand, EnGenius was the first to launch 11ax into the small, medium-sized business market, and we continue to launch new products, and Eddie will talk about one of those products later. So EnGenius has launched multiple Wi-Fi 6 access points, which Microcom is currently selling, so that's great. The first one is a 4x4 11ax, or a Wi-Fi 6, I should call it now, managed access point solution, which fulfills the Wi-Fi connectivity demands and high client density in small and mid-sized businesses. This is truly one of my go-to access points for, I would say, 100% of the installations I recommend, unless there is a pricing or a budget constraint. This is my go-to. Even if there's a budget constraint, which we are probably the most aggressively priced 11ax product out there, which a budget constraint would be, we don't run into often, but this is my go-to. So this was really developed to meet the needs of today's future high density clients, which is becoming more relevant. It enables SMB customers with a solution for highly concentrated Wi-Fi areas, such as large training rooms and beyond. Supports existing and future device and application needs. It's backwards compatible with legacy Wi-Fi client devices like A, B, G, N, and even AC. It really re-energizes the capacity reach of 2.4 and 5 gigahertz. So this is a great solution for a lot of different scenarios. This retails for $499. It's a ceiling mount access point, operates on all the different 802.11 standards, AC, A, G, N, B is not mentioned, but B also, AX. This provides 2.4 gigabits per second on 5 and 1.1 on 2.4 gigahertz. It's a 4x4 design with 3 dBi antennas. It has a single port, which is 2.5 gigabit for faster speeds. It does have adjustable output power of 23 dBm. It's PoE plus. Surprisingly, this is only 17.5 watt maximum power consumption, which is a big deal. It's just more efficient. We do support WPA2 and the new WPA3 wireless security. And this device can be configured with EasyMaster, which Eddie will talk a little bit about, but more importantly with the SkyKey, which he'll talk about. You have captive portal, guest networking, seamless roaming. So with that said, I'll pass this off to Eddie Lee to round out this presentation.
Thanks, Brian. Brian already talked about the 4x4 Wi-Fi 6, which is Microcom currently have, and again, that is also my go-to product. If you have customer wanna, hey, I want the latest, greatest wireless access point 4x4 AP, is always the go-to product. So, but again, Brian also mentioned about we not only have a 4x4, we also have a 2x2. The model number is EWS 357 AP, and there's another one coming. It's on our roadmap. It's called EWS 376. It's also 2x2 and 4x4. It's kind of like we have a good, better, best, but the EWS 377 is the best one. So I just want to let you know we have comprehensive Wi-Fi 6 portfolio. So so the next we're gonna talk about is also the Wi-Fi 6. We have indoor. We talk about indoor. And EnGenius will be the industry first launch Wi-Fi 6 outdoor access point. So it's 2x2. So you may ask, what's the 2x2 and 4x4? What's the difference? So 4x4, you have a total 8 antenna building. So you have a 4 receive, 4 transmit, and 2x2. If EWS 850, we have 2 external. Total four external antenna, 2 for 2.4 and 2 for 5 gigahertz. So spec-wise, 2x2 support up to 1200 on the 5 gigahertz and 574 for the 2.4 gigahertz with a 5 dBi external detachable antenna and IP60 waterproof and dustproof housing. We have 2 gigabit Ethernet port. That is all the customer need for, especially the Wi-Fi 6 is not only for the indoor, even the outdoor. Brian already talked about all the device grow. You gotta have more device, BYOD device with you, if not only indoor, also the outdoor. So Wi-Fi 6 outdoor is very high demand in the market right now. So we talk about indoor, outdoor. You probably will ask, how about the point-to-point? Yeah, that is what I'm gonna talk about. The point-to-point, we also have point-to-point Wi-Fi 6 on roadmap, and the target schedule is about like Q2, probably end of the Q2, because a lot of people ask about, oh, I need a Wi-Fi 6 point-to-point, more efficiency, and there's a lot of benefit for the Wi-Fi 6. So I just want to let you know, it's not on the slide, but I just want to let you know it's on our roadmap. So okay, so we talk about Wi-Fi 6, how efficiency, why you want to use the latest, greatest technology. But for the Microcom customer, the next question that they will ask you is, they need quickly, easily manage access point or even switch. What is a EnGenius or any other vendor offer that? Yeah, the SkyKey is the one. So SkyKey, there's a very intuitive interface and simple plug and play. You don't have, there's no installation requirement. So there's two key benefits. One is the simplicity, one is efficiency. So simplicity, just I mentioned, it requires no complex installation or integration. So simply just plug and play. So if you are IT manager, a system integrator, you try to save more time. If you can save more time, you can do more project. So SkyKey, instead you spending the hour to set up the controller or install the EasyMaster, you can simply running within minutes instead of hours. So the network management software EasyMaster is integration automatically installed, so no additional download or configuration needed. So again, like I mentioned, it's very intuitive interface, no technical expertise or training is required. So just few click, you'll be able to manage all the EnGenius access point, including the EWC 77 we talk about, and also EWS 850. And also the efficiency, SkyKey provide a single place. If you can see the screen, provide a single place, you can view the status, analytics, and the most important, you can manage up to 100 access point and switch. Again, SkyKey can manage up to 100 access point and switch. So with all the detailed information, IT manager or IT administrator can view all the data in single location. So it gives you all the rich reporting, analytics, and give you all the information. Again, just plug and play installation, no complex installation required. All right, I'm gonna pass to Brian. So
Yeah, so I know we're kind of stretched on time. So just really quick, you might ask, you know, are there a lot of 11AX clients out there today? And yes, we can say that there are. The new iPhone, the Samsung S10 are all 11AX. With our testing, with 11AC client devices and 11AC 11AX devices and 11AC client devices, you definitely see a gain of about 300%. So even if the 11AX access point is going into an environment with older client devices, you still see a huge gain. As you add devices to the network, if it's 11AX access point, the 11AX access point over the time will perform better and better and better as the client devices are updated with 11AX and so on. So I just wanted to throw that out there. And what we'll do now, Julie, is open it up for any questions that you may have. So I'm sorry, we're over time by 2 minutes, I think. So.
Thank you very much, Brian and Eddie, for that wonderful presentation. Don't worry about time. We're happy to accommodate this. We do have some questions for you, so let's get started with the first one. Let's see, going back to your discussion about wireless devices per person, can we talk again about material that you have showing wireless devices per person forecasted for the future?
Say that again. I'm not sure what's the question again? Sorry.
Oh, sure, no problem, no problem. We have one of our audience members wanted to ask about material that you have showing the amount of wireless devices per person that is being forecasted for the future.
Oh yeah, if you do, is the request for the data? Are you looking for the data set?
Material showing.
Okay. Oh yeah. So yeah, if you just do a search on Cisco Visual Network Index, there's a great report out there that covers in way more detail, obviously, than what I'm showing here, but shows that information within that report. It's called the Cisco Visual Network Index. And they also share a lot of additional information such as this breakdown, for example, wired versus wireless and wired, you know, and the trends for that too. So yes, it's Cisco's Visual Network Index. And that report's used with a lot of different companies.
Excellent. Thank you so much. That'll be valuable for us to have and to check into that.
Oh, yeah.
Next question here for you. Okay, terrific. Thank you. How does 5G fall into play with EnGenius? You talked a little bit about that.
Oh, so right now well, it really doesn't because we don't have a 5G solution. In regards to cellular, right, data communication, but they coexist. They can coexist. Like our devices can coexist with 5G devices. But the trend is that the current trend is that a lot of cellular devices, or there's a lot of offloading, is what they call it, offloading. So when, for example, I'll give you an example of that. When I'm on my cellular phone and I'm in my car and I'm driving and I get to work, for example, my phone will jump over to the Wi-Fi network. So the data is being offloaded to the Wi-Fi network versus the wireless networking. And so So you're talking about two things. There's cellular and then there's Wi-Fi. 5G is a cellular technology. It's supposed to be the newest cellular technology, and Wi-Fi is obviously operating on 2.4 gigahertz and 5 gigahertz. So we don't have a solution around 5G. So long-winded answer, I guess, for that. Hopefully that answered the
That's
question.
okay. It's understood, Brian. Thank you so much for clarifying. Thank you very much for that. Next question here for you. Is Wi-Fi 6 considered a Wave 2 product, or have we now surpassed that?
Well, yeah, because when we talk about Wave 1 versus Wave 2, you're referencing 11AC or 802.11.11ac. When 802.11.ac came out, there was a lot of features within 11AC, and they presented, when the first portion of the standard came out, they could only do, say, I'll give you an example. This is not actual, but they gave us 50% of the features that 11AC could do, and that was Wave 1. So Wave 1, we could provide you with 11AC, but it was Wave 1 because it only had 1 through 5 of the features of 11AC. When Wave 2 came out, Wave 2 gave us from 1 through 10 features of 11AC. So Wave 2 was just another rendition of 11AC. Now with Wi-Fi 6, Wi-Fi 6 is a totally new, not totally new, but very new Wi-Fi standard. It's a 100% new standard. And from what we understand, there will be a Wave 1 11AX and there will be a Wave 2 11AX, or a Wi-Fi 6 Wave 1 or a Wi-Fi 6 Wave 2. So more and more features are added as we move forward. So hopefully that answers that question.
Yes, thank you so much for that, Brian. The next question here for you. Again, someone's chiming in on Wi-Fi 6. Is that simultaneous connections to 2.4 and 5 gigahertz on a device?
Yes. Yep.
Thank you so much. Next question here for you regarding SkyKey. You say it supports up to 100 devices at a time. What if we have more than 100 devices?
Then you either would move to EasyMaster server, or you would add another SkyKey device. But now you segmented the two SkyKeys, and now the IT administrator is logging into the individual SkyKeys. So if you're going beyond 100, you'd probably move to an EasyMaster server, for example. An EasyMaster can be implemented on a server or AWS. It's really dependent on the needs of the environment, the budget of the environment, the technical know-how of the particular person installing it.
Excellent. Thank you very much. Just a couple more questions here for you.
Sure.
Will EnGenius be implementing Wi-Fi 6 via all of the devices via an update?
No, Wi-Fi 6 is a new standard, so that takes a whole new chipset to be able to do that. So it's a hardware. There's a hardware difference between a Wi-Fi 6 device and a Wi-Fi 5 device or 11AC device. So the 11AC devices that are out there today are produced on a particular chipset, and that chipset is 11AC, for example. 11AX, the advancements are so vast that you have to move to a new chipset. So it's not a simple firmware update. It's a physical change within the hardware. The hardware is totally different. So it's
understood.
when you're looking at Wi-Fi devices, you're looking at a totally brand new device.
Excellent. Thank you for that clarification, Brian. Appreciate it. Last question here for you. In terms of Wi-Fi connection, would you say that you are more advanced compared to your competitors?
Wi-Fi. Could you ask that question one more time?
Sure. In terms of Wi-Fi connection.
Yep.
Would you?
Do you mean the simultaneous users, or what is that? Like the actual connection itself? Oh, okay. Simultaneous users. No, I say that we're very, very similar into how many devices can connect. I think the question is how many devices per access point, or how many simultaneous clients can you have per access point? I think that's what the question meant to be, possibly. No, I would say that we are similar to all the vendors that are out there. But when you talk about Wi-Fi 6, my Wi-Fi 6 versus our competitors' Wi-Fi 11 AC, then yes, we're definitely more advanced. But if you're talking about my Wi-Fi 6 versus somebody else's Wi-Fi 6, we're very, very similar. We're using the same technologies. They may use a different chipset than we use, so the techniques might be a little bit different. But it also comes down to the CPU on the actual device itself. It comes down to the memory of the device itself. So that's why Eddie and I really pressed on the EWS 377 AP, because the makeup of that product, the hardware, one, it's using Wi-Fi 6, but the memory on that device, the CPU on that device is advanced. The antenna structure, or the antenna, the number of antennas on that particular device will handle a lot more devices than your average 11 AC Wave 2 access point, or even your business class 11 AC Wave 2 devices that are out there. And I don't mind throwing out. If you look at our 4x4 Wi-Fi 6 and you compare it to a Ruckus, a Aerohive, a Meraki, for example, Wave 2, 11 AC Wave 2 4x4 access point, our access point is going to outperform that access point, no problem. If you're comparing us with Wi-Fi 6 to Wi-Fi 6, it'll be very, very similar. So it just really comes down to the access point you choose and what you're comparing it to.
Excellent, Brian. Thank you so much for making that distinction. Yeah.
Let me give you another example just really quick. So just to give you a little bit, give the audience a little validity to validate, I should say, with EnGenius, right? So we just did a New Year's Eve event in Taipei at the 101 building. There were 20,000 users at that particular event. It was 2020 New Year's Eve event. They had huge performance, 20,000 people. I think it was 108,000 square feet, and we used a combination of two Wi-Fi 6 access points in that venue. And we were able to support, I think the max at the time when we were looking at while the network was running and while this party was going on, we had 6,000 concurrent users on that network. Now, we had 111 access points in that scenario, but 6,000 concurrent users on that network, that is huge. And so that gives you an idea of what Wi-Fi 6 can do for a network and what EnGenius's Wi-Fi 6 can do for a network. So just to give you a little more validation in regards to like our solution and Wi-Fi 6, that is a really good validation. And that case study will come out within a week's time frame. So we'll share that with everybody, and I'll be sure to send that to you via email also.
Brian, thank you so much. That was impressive. I liked hearing that. I appreciate it so much, and thank you for answering all those questions. And thank you to Eddie for joining in on the presentation. We enjoyed it very much. If anyone has any further questions, of course, please feel free to contact your sales rep and email us at sales@microcomtech.com. If you wish to view any of the products mentioned or shown here today, please visit us at www.microcom.us. And remember, this webinar presentation has been recorded and will be uploaded to our Microcom YouTube channel so you can view it again. Thank you so much, Brian, and to Eddie. Appreciate your time and everything today. Have a fantastic day, you guys.
Thank you.